good afternoon, everyone, and welcome to the continued educational webinar series by Algorithmic Traders Association. My name is Alex Christop. I'm the Director of Educational Programs with Algorithmic Traders Association. And in this webinar, we're going to discuss the subject with perhaps the most notorious reputation among all parts of systematic trading. And its name is optimization. We are going to consider the very definition of optimization, its applicability to trading systems, and finally come to a conclusion whether it really deserves such a disdainful attitude. Optimization was brought to systematic trading from mathematics, and as many special mathematical terms used outside of its main application domain, it has slightly different meanings in different domains. For example, optimization of human resources most often means a number of guys being fired. Optimization of debts most likely means that creditors won't see their money ever again. Unfortunately, in trading, optimization also doesn't have the same meaning as it does in mathematics, and therefore is understood a little bit improperly. Let's start with how optimization is understood in trading, and then let's see how it corresponds to its original mathematical meaning. I'd like to make a remark for all those who have decent background in mathematics. All the following discussion will be dedicated to how optimization is understood in the trader's world. And of course, we will use this term in a somewhat limited sense. In trading, optimization is used to denote the process of adjusting the parameters of a trading strategy so that its performance would be the best. Hopefully, you can immediately see the bottleneck of this interpretation of optimization. It requires certain criteria to judge whether the strategy performance is the best or not. And depending on these criteria, we may come to very different results. Before we proceed, I would like to make a general disclaimer for any attendees with decent background in mathematics and especially in optimization. Everything we're going to discuss today will be far less formal than you are accustomed to see. Please understand that this webinar is not intended for academic researchers whose interest might be to find new applications of advanced mathematical methods to trading. This webinar is intended for traders with very different background and mostly without any background in mathematics at all. Therefore, we are not going to discuss advanced mathematical problems, but rather focus on how optimization is understood and used in systematical trading, and in the long run, whether it helps making money in markets or not. Enough said about the purpose of this webinar, and let's start with optimization criteria. What are optimization criteria and why do we need them? Optimization criteria are metrics, or speaking in more simple terms, numbers which serve to tell good results from bad ones. We use metrics every day. For example, if we want to compare two pizzas, then most likely we would start with comparing their ingredients. If they're the same, then we would compare their weights. If the weight is also equal, then we'd proceed to comparing price. In this example, we use different metrics, and at each step, the result of the choice could be different. When we want to compare two trading strategies, we also need a metric or a number of metrics to be able to quantitatively assess their properties. Among these properties, in most cases, we can be interested in performance. However, sometimes other properties could be of greater interest, for example, capacity and scalability. Nevertheless, In most cases, when we talk about optimization, we mean the strategy performance, or in simpler terms, profitability. Typically, we compare strategy performances using either immediately calculated or benchmark-based metrics. Immediately calculated metrics are those which can be derived immediately from the strategy performance data. The most heavily used metric of this kind is, of course, net profit, because in the long run, everyone wants his strategy to generate as much money as possible. Other popular immediately calculated metrics are profit factor and return on account or return on drawdown. Benchmark-based metrics use extraneous data to compare the strategy performance. The most well-known metric of this kind is Sharpe ratio, which uses returns in S&P 500 as a benchmark. Now, as we are familiar with how to compare strategy performance using metrics, we can express the classical optimization process in the following schematic picture. We start with setting all strategy parameters to some initial values, running a backtest. Please refer to our previous webinars about backtesting, and calculating a metric. We record the metric's value along with the values of parameters which generated it. Then we modify the values of parameters and record a new value of the chosen metric. We repeat this loop until all combinations of parameters are enumerated. Finally, we simply select the maximum value of the metric along with the respective values of the strategy parameters, and here we are with an optimized strategy. A metric which is used in this process is called target metric. The optimal parameters found in the process which we have just considered are normally used in live trading, and it is not infrequent when a strategy optimized this way quickly loses its momentum when trading live or doing any other kind of forward testing. Why? Because no single target metric is able to describe all the important features of a trading strategy performance. Let's consider an example. It is important to note that as the result of this procedure, only one set of parameters is chosen, the one which generates the best or the maximum value of the target metric. Therefore, all three performance curves or equity curves presented in this slide fully satisfy the requirement of a particular metric to be maximal. However, it's obvious that in the leftmost picture, the strategy was most likely optimized to feature the least possible drawdown, but it works only less than 10% of the time. In the middle picture, the net profit is maximal, but the drawdown is huge. And in the rightmost picture, the profit factor is probably great, but the strategy's future is very doubtful. This is the very issue which is most frequently pointed out by opponents of optimization. They may sound right, were it not for the fact that no single target metric is able to present all the important features of the given trading strategy. This is what we did. We maximized the value of a certain target metric and we totally disregarded any other metric. If we'd want to illustrate it with a graph example, then the best illustration would be simply a search for an extremum of a two-dimensional function. In most cases, it is always possible to find. But what if we want to maximize more than one parameter at a time? For example, to go for the maximum net profit and the minimum drawdown at the same time. This task cannot be solved in general form using maximization of a single metric, because in the absolute majority of cases, with trading strategies, maximizing one target metric would corrupt other metrics. For example, maximizing the net profit would decrease the average trade value in most cases, and minimizing the drawdown would decrease net profit, and so on. Therefore, we should replace a task of finding a maximal value of a single target metric with an optimal value, which is always a compromise between a number of metrics. This way, we replace the two-dimensional task with a multi-dimensional one. For example, in this simple illustration, you can see that the net profit is highly dependent on values of other metrics, and selecting just the maximal value could not be the best idea. The domain of mathematics, which studies methods of finding extremums in multidimensional space with constraints and boundaries, is indeed very complex and requires decent background in mathematics to use it fluidly. But, as is frequently the case with most complex matters, it can be illustrated with a relatively simple example. Let's go back to our example with the choice of pizza. We have a number of metrics which we use, even unconsciously, when we choose one: contents, size, price, and so on. And every time we have to make a single choice, this choice is always a compromise between these metrics. It's unlikely that we choose a pizza which is the cheapest one, but at the same time the smallest. It is also unlikely that we choose the one which is large and cheap, but which taste we don't like. Therefore, we would most likely choose not the cheapest and not the most expensive, not the biggest, not the smallest one. Thus, we have come to probably the most important, I'd even say the cornerstone fact about optimization, that the truly optimal solution never has any of the metrics at its maximum value. Let me even repeat it once again. The correctly found optimal solution, in case it is really optimal, would never include any maximal value of any metric. Please remember that optimization is always a compromise, and the compromise is something that lies aside from any extremes. By the way, this is true not only for mathematics, but also for our life in philosophical sense, but it's a completely different story. Now, here comes another question. If we are not able to find the really optimal solution to our problem of optimization by simply maximizing a single metric, then what is the correct solution to this problem? To solve it, we can use so-called objective functions. In simple terms, combinations of various important metrics with an expression or an algorithm which with a single output value, and theoretically finding a solution which maximizes such an objective function would deliver the optimal set of parameters to the trading strategy. For example, maximizing net profit, so maximum drawdown ratio, could help finding trading rules which feature high net profits with small drawdowns. Of course, this is only an example, and real objective functions are normally more complex. Fortunately, it is possible to do in some modern software for backtesting and optimization. Here is extremely important to note that the very choice of the target metric and the choice of the objective function are not obvious and may heavily depend on the properties of the traded market rather than just the researcher's discretion. Moreover, I really want you to understand that no objective function and no specific optimization method is a holy grail for trading systems developer. Therefore, let me repeat once again the same main idea which I'm humbly trying to present in all my webinars, that only understanding the market and its peculiar features is able to allow for development of robust trading strategies and consequently applying various methods, including optimization, to improve this strategy. And now we're ready to get back to the answer and find the answer to the initial question about optimization, whether it can be a useful tool or it's simply misleading. As we can see now, if optimization is performed in the correct way, then of course it may help developing robust trading strategies quite a deal. On the other hand, if optimization is used erroneously without regard to the trading idea used in the particular trading strategy, for example, when optimization is confused with maximization of a single target metric, then indeed such a strategy, or rather a strategy with these parameters, most likely will not be very usable in real life. We are already mentioned today that optimization in its mathematical sense is a very complex subject and cannot be discussed in all details within a single webinar or even a series of webinars for traders without decent mathematical background. The good news is that we don't really need all this mathematical background to make money with systematical trading. Moreover, it's very important to understand that neither optimization nor backtesting nor any other applied mathematics will be able to take you to the profitable zone without the proper understanding of the market itself. We have developed a very special course for systematic traders which includes exhaustive market research. This research not only allows to design simple and yet consistent trading strategies, but it also features all the essential trading in backtesting and optimization in its specific meaning, of course. So if you want to improve your knowledge in optimization and its academic sense, and to be able to discuss the subject the most precise terms, then you'd rather go for a university course, especially that there are quite a few of them freely available nowadays. But if you're looking for a less formal but more practical application of this domain of science, then definitely our CAT course is the way to go. Now I would like to say thank you for your attention, and in case you need more information about our educational program and certification, please just feel free to write to info@atssm.com. You can also do that by filling up a form at the classes page of the site. And now the main part of the webinar is over, but for interested attendees, I'm going to say a few words about the CAT course program, and if you want to learn more, then simply please stay tuned. The CAT, or Certified Algorithmic Trader course, includes 3 stages. First, we start with the market analysis. Next, we work on the design of algorithms, on backtesting and optimization. And finally, we discuss the design of portfolios and risk management. First, we analyze the market and consider it as a superposition of human actions. Please refer to our previously recorded webinars on this subject that are freely available at our YouTube channel, youtube.com/ATASSM, where I explain this standpoint. Next, we learn how to identify viable trading ideas which work in the market. And finally, how to transform these ideas into algorithms and ready-made programming codes. Next, we heavily work with backtesting. We learn how to properly run the backtest, how to assess the robustness of the strategy, how to make sure that the test is realistic, that it accounts for all possible unpleasant situations in the market. And also we discuss how to use optimization. We work with exhaustive optimization, genetic optimization, walk forward, and many other interesting things. And we learn how to use optimization mostly as a means of research rather than just curve fit the model to the market. And therefore, how to avoid the most popular traps of optimization when an over-optimized strategy doesn't work in the real market. And finally, we discuss the most complex and most interesting things, how to create robust portfolios. And here we discuss portfolios that consist of various markets and various strategies. For example, we can have 3 markets and 5 strategies that trade each market. Therefore, we allow for greater risk diversification. And this is, in my opinion, the only way to survive the modern changing markets. We learn how to manage operational and systemic risks and how to identify the moment when it's important to switch off a trading system. Sometimes this decision becomes the most practical one. And therefore, we encompass the full lifetime of a strategy, from its development to its end. Normally, such a course takes about 3 months. I say about because normally we work a little bit more, especially in case students require some more time to understand, to work on certain subjects. We meet once a week online using screen sharing software, and I explain new topics, things, I show how to do certain things, and then all students are assigned a homework, and the rest of the week is spent in emailing. Students do the homework, they ask me questions, send reports, share results, make suggestions, and so on. So I reply only not live immediately, but using email. But nevertheless, please understand that it is not just a weekly entertainment. This is a really hard work that lasts for 3 months. We work in small groups. Normally we work on individual basis, or perhaps 2, maximum 3 students, and I always try to make groups consisting of students with a similar background, similar starting level of knowledge, and so on. We require some only basic mathematical background. I mean that basically you need to be able to do the 4 arithmetical operations and have a general understanding about statistics, to know what is the mean value, to understand what is a standard deviation, perhaps, although I explain all these terms in the course, of course. As to the basic programming skills, I think anyone who ever programmed successfully, even the simplest algorithm, of course, will be able to program strategies which we consider. And experience with programming, of course, is a plus, and experience with trade-essential multi-charts is also a plus, because we use mostly multi-charts in all our works, because first, it features easy language, which is extremely convenient for writing simple algorithms, and therefore makes the learning curve very steep and saves a lot of time on programming. And on the other hand, this is a really decent software with a very reliable backtesting engine, so we can trust the results of backtests with this software. And it features a really great portfolio backtester, which allows us to create robust portfolios. So this is more or less all about it. And again, I would like to say thanks for your attention.